Today's session we will see some problems on Fourier series. These problems have come in various competitive examinations including GATE exams. Some of the problems which we are doing today are from earlier GATE questions also. Okay, let us start with the first problem. The first problem, let me read. A periodic function f of t is said to have half-wave symmetry if f of t is equal to. Okay, a periodic function f of t is said to have half-wave symmetry if f of t is equal to. The choices are A minus f of t, B f of t plus t by 2, C minus f t plus or minus t by 2, and D f of t minus t by 2. Okay. Here the small t indicates the functional time and the capital T indicates the period of the signal. So the answer is, we are talking about a periodic function which is having a half-wave symmetry. So the answer is this, C, that is minus f of t plus or minus t by 2. So this is what the function is said to have half-wave symmetry if it satisfies this condition, minus f of t plus or minus t by 2. Okay. Let us start the second question. The second question is as follows. Any periodic function can be expressed by a Fourier series. The function has finite number of finite discontinuities in a period, infinite number of finite discontinuities in a period, finite number of infinite discontinuities in a period, infinite number of discontinuities in a period. If you remember, we have seen the Dirichlet's conditions earlier, where the Dirichlet's conditions help us in identifying whether a Fourier series exists, and it also gives 4 sufficient conditions. Based on that conditions, let us find out what is the answer for this question. As you see here, for a periodic function to have Fourier series, it must have finite discontinuities in a finite amount of time. So the answer is finite discontinuities in a period of time. If it is having, the second question says anything which is infinite discontinuities, there cannot be a Fourier series which converges. So we say that the answer is A. Let us see the third question. The third question is, a trigonometric series has A single-sided spectrum, B a double-sided spectrum, C both single and double side, and 4 none of the above. If you remember my earlier session, here there we have described very clearly there are different types of Fourier series. One is a trigonometric Fourier series, the other one is a complex exponential Fourier series. There we have clearly mentioned the trigonometric Fourier series will have only one-sided spectrum, whereas a complex exponential Fourier series is double-sided. So the answer is obvious. Let us see what the answer is. The answer is, it is a single-sided spectrum. So it will have only on the single side. Okay. So it will have something like this spectrum. As you see here, this is existing. As you see here, this is existing only on one side of the axis. That's why this is called as a single-sided spectrum. Let us see question number 4. Fourth question. An exponential Fourier series has a single-sided spectrum, choice A, that is. Choice B is a double-sided spectrum, that is choice B. Choice C says it is both single-side and double-side, and D is none. So as I have explained in the earlier question, trigonometric Fourier series will have a single-sided spectrum, whereas exponential Fourier series will have a double-sided spectrum. So the answer is B. Okay, so it will be a double-sided spectrum. Let us see this on the board. Okay, so double-sided spectrum means what? A spectrum exists on both sides. Okay, so it will also be existing here. Okay, as it is existing on this side and also this side, this is called as a double-sided spectrum. The question number 5 is as follows. Which of the following conditions is incorrect for a function f of t which can be represented in a Fourier series? A. F of t has no finite number of discontinuities. B. F of t is equal to f of t plus t. C. Minus integral of minus infinity to plus infinity x of t dt exists. D. F of t has finite number of maxima and minima. So we have to be a little careful while answering these type of questions. These type of questions are basically, if you are in a hurry to give the answers correctly, then there will be a small problem here. So what you have to do is be a little patient while reading the problem itself. So, okay, here the problem states that we have to identify the incorrect statement and not correct statement. Generally, if you look at the probability of questions being asked, most of the questions are based on identifying the correct answer. Suddenly a question is given where you have to identify an answer which is incorrect. So you have to be a little careful while reading those type of questions. So if you look at this question, it's all about Dirichlet conditions. There are 4 Dirichlet conditions and 3 of them have been given here correctly and 1 of them is wrong. So we have to identify what is wrong. Okay, so let us eliminate one by one. The first is, we are saying that f of t has no finite number of discontinuities. No finite number of discontinuities means what? It is having infinite number of discontinuities. So Dirichlet condition says this is not true. So the answer A is the wrong. But here it is a correct answer because we have to identify the incorrect answer. So A is the answer here. Okay, similarly, if you identify the other 3 parts, we just analyze B, C and D here. The second one says f of t is equal to f of t plus t. We said one of the conditions for Fourier series to exist is f of t must be periodic. So f of t is equal to f of t plus t indicates that it's a periodic signal. Okay, and C says the integral minus infinity to plus infinity x of t exists. That means its value is less than infinity. That is again one of the Dirichlet conditions. And the final D says here that it must have finite maxima and minima. We should have finite maxima and minima. That is another Dirichlet condition. So D is also true. So B, C and D are true as per Dirichlet conditions. But here, because we are answering a question which says that what is the incorrect, so we have to put the answer as A. That's what we have given here. Let us look at the 6th question. The frequency spectrum of a periodic signal is discrete, continuous, both discrete and continuous. Obviously the question is very confusing because an answer cannot be both discrete and continuous. Probably under certain conditions discrete, certain conditions it is continuous. But anyway, we shall look at that again later. D is none of the above. The question is, the frequency spectrum of a periodic signal is discrete, continuous. These are the 2 questions which we have to look at, and whether after identifying whether it is discrete or continuous, we have to identify whether both it is continuous under certain conditions or discrete under certain conditions, or it can neither be continuous nor discrete. Let us see the question. Okay, the frequency spectrum of a periodic signal is discrete. That's the answer. Okay, as we have drawn for the earlier question, when I am showing the spectrum we have shown as discrete components, isn't it? Discrete parts. So the frequency spectrum of any Fourier series is always discrete. So the answer is discrete. Now we can eliminate C and D are automatically eliminated because you know very clearly what is the answer. The 7th question is, the frequency spectrum of a non-periodic signal is discrete, continuous, C both A and B, and D none. See here, the frequency spectrum of a non-periodic signal is continuous. So that is the answer for this. Let us see the next question. 8th question. The question is, the amplitude spectrum of an exponential series is dash about the vertical axis. So what are the choices? Choice A, it says it is anti-symmetrical. B, it says it is symmetrical. C, it can be either anti-symmetrical or symmetrical, and D, none of the above. So we are talking about the amplitude spectrum of a exponential series. We are trying to find out whether it is symmetrical or anti-symmetrical, or it's neither. Okay, let us say this is the amplitude which we are talking about. This is the spectrum of this is the amplitude spectrum of any exponential series. If you look at this, the right hand side and the left hand side, there are both mirror images. So the answer is symmetrical. This is the spectrum which always will be present in an exponential Fourier series. Okay, so let's see what is the answer. The answer is it is symmetrical. Let's look at the 9th question. The 9th question says, the phase spectrum of an exponential series is blank or dash about the vertical axis. Okay. Earlier question was amplitude spectrum, and this question is talking about phase spectrum. So we have to find out what is the answer for this. The phase spectrum of an exponential series is dash about the vertical axis. A, antisymmetrical, B, symmetrical, C, it can be either antisymmetrical or symmetrical or both of them under certain conditions, and D is none. The answer is the phase spectrum of exponential series is antisymmetrical about the vertical axis. Okay. So, if you summarize the earlier question and this question, if you remember both these questions, remember always an exponential series of Fourier series, amplitude spectrum is symmetrical, whereas phase spectrum is antisymmetrical. If you remember these two, any question asked in any manner, you can answer it correctly. Let us see the 10th question. The 10th question says, the time domain representation of a signal graphically is called A, waveform, B, spectrum, C, amplitude, and D, phase. Okay. So, what is it we have to answer here? The question is, the time domain representation of a signal graphically is called a waveform, a spectrum, amplitude, and phase. Okay. Let us just see this on the board. Let us say I have a signal here. Okay, certain, or let us say amplitude. So, this is the time and this is the amplitude. So, this is called as a waveform. Any time domain, I repeat, any time domain representation of a signal is called as a waveform. So, the answer here is waveform. Let us see the next question. The next question is, the frequency domain representation of a signal graphically is called A, waveform, B, spectrum, C, amplitude, and D, phase. Okay. So, what is the frequency domain representation of a signal is called? Is it called as a waveform? Is it called as a spectrum? Is it called as an amplitude, or is it called as a phase? Let us see this. Let us say I have, this is the frequency, this is the amplitude. Let us say I have a signal here, again frequency components here. Let us say this is f0, this is f0 plus some fm, let us say, and this is f0 minus fm. Similarly, a signal at minus f0 also exists, and this is 1 and this is 1. So, these are all separated by a certain frequency. Okay, if you look at this, we are trying to see frequency components existing at certain frequencies. So, this type of graphical representation of a frequency, this is a frequency domain because we are taking the y-axis of frequency. So, this type of representation is called as a spectrum. Earlier we have seen a time domain representation which is called as a waveform, whereas if I represent this with x-axis as a frequency, this is called as a spectrum of the signal. Okay. So, we are seeing one famous spectrum here. So, let us see what is the answer. The answer is of course spectrum. Okay. So, the frequency domain representation of signal when it is represented graphically is called as a spectrum. The frequency domain representation of a signal graphically represented is called as a spectrum, whereas the time domain representation of a signal graphically is called as a waveform. Let us read the next question. The next question is, Dirichlet conditions are dash conditions for the existence of the Fourier series of a function f of t. A, necessary, B, sufficient, C, both necessary and sufficient, and D, none. So, the answer is, whenever we have written or spoken about Dirichlet conditions, we said that these are sufficient conditions. The answer is B, that is, these are sufficient conditions. The answer for this is, we have earlier seen, it is sufficient, not necessary. Okay. So, these are the 4 conditions are sufficient conditions for a Fourier series to exist and also converge. Let us see the next question. The next question is, the relation between the polar Fourier coefficient Dn and the exponential Fourier coefficient Fn is dash. That means, we have to give the answer which indicates a relationship between the polar Fourier coefficient denoted by Dn and the exponential Fourier coefficient denoted by Fn. Okay. Choices are A, dn is equal to fn, that is the polar Fourier coefficient is equal to exponential Fourier coefficient, that is the first choice. The second choice is the polar Fourier coefficient is equal to twice the exponential Fourier coefficient, that is fn. Okay, dn is equal to fn. The C is the polar Fourier coefficient dn is equal to twice the mod of exponential Fourier coefficient fn, and D is 2 times the value of polar coefficient dn is equal to the exponential Fourier coefficient fn. The answer is the polar Fourier coefficient dn is equal to twice the mod of the exponential Fourier coefficient. So, you should be very careful in marking this answer, because there seems to be a lot of relationship between C and B, and also if you are a little unaware, even D seems to be similar to the answer. So, be careful and put the answer as dn is equal to 2 of mod fn. So, let us see the next question. The next question is, the polar Fourier series is also called dash Fourier series. The choices are exponential, complex, harmonic, and D, none of the above. As we have seen in our discussion earlier, the other name which we have given to polar series of polar Fourier series is harmonic Fourier series. So, the answer is C, which happens to be harmonic. Okay? The polar Fourier series is also called as a harmonic Fourier series. The next question is, the coefficient an is 0 for dash functions. Okay? If you remember the Fourier series, in the Fourier series there are 3 different coefficients which you have seen. One is a0, which we said is average, then an is a coefficient of cosine function, then you also seen bn, which is the coefficient of sine functions. So, here we are talking about the coefficient of cosine function, also called as an. So, the question is, the coefficient an is 0 for dash type of functions. A even, B odd, C both even and odd, and D none. So, the coefficient an is 0 for even functions or odd functions, or it is 0 for even and odd functions, or it is none of the above. The answer is the coefficient an is 0 for odd functions. For odd function, the coefficient of the cosine is 0. Let us see the next question, 16th question. The 16th question says, choose the function f of t defined over a region minus infinity t to infinity, for which the Fourier series cannot be defined. We have been given a lot of functions in which we have to find out for which Fourier series cannot be defined. A is 3 sin 25t, B choice is 4 cos 20t plus 3 plus 2 sin 710t, C exponential of minus t sin 25t, and D is equal to 1. Okay. We have to choose the function f of t for which a Fourier series cannot be defined for a region given minus infinity to plus infinity. The first function is a sine function, second function is a sine function plus a cosine function, third function is exponential function, and the fourth one is a 1. So, the answer is C, that is exponential function e to the power of minus t sin 25t. We have gone through the differential conditions and we have seen that the answer is C. Let us see the next question, 17th question. If an and bn are the Fourier coefficients of trigonometric form of Fourier series and Cn is a Fourier coefficient of exponential form of Fourier series, then which of the following is not true relation? So, we have to again find out the answer which is not true. That means, in the given choice of 4, 3 must be true, only 1 is wrong. The one wrong answer as per the condition is our correct answer. So, how do we justify this? Now, we have to see. Okay. What is we are talking about is we have to find out what is the relation between the coefficients a and bn in Fourier trigonometric form and Cn in complex exponential form. We have to find out what is the relationship, and we have to see which are correct and identify which one is not correct, and the answer which is not correct is our correct answer for this, because we have to identify which is not true. Okay, let us see A. The choices are A, Cn is equal to half an plus jbn. B is Cn is equal to half an minus jbn. Then C is equal to C of minus n is equal to half of an plus jbn, and D is equal to Cn mod Cn, which is a part of Cn. Okay, the answer is A, that is Cn is equal to half An plus Jbn is not a true relation. Okay, let us see the 18th problem. A signal x of t of time period pi has a Fourier coefficient Cn is equal to 4 cos k pi by 2 by k pi. Then Fourier coefficient of x of t 2t minus 1 by 4 is what? The choices are A, 4 cos k pi by 2 by k pi, exponential of j k pi by 4. Choice B is 4 cos k pi by 2 by k pi e to the power of minus j k pi by 4. C, 2 cos k pi by 2 by k pi into exponential of j k pi by 4. And D, 2 cos k pi by 2 by k pi e to the power of minus j k pi by 4. Okay, well, here we will just see the time shifting property of Fourier series, okay, before we actually solve this problem. So, let us say if x of t is having Cn as a coefficient in exponential Fourier series, when I shift this, so when this is shifted by a certain time, the answer Cn actually will get multiplied by minus jn omega naught t naught, where t naught happens to be the time shift. The significant part of this is Cn does not change. That means the coefficient of the complex exponential series does not change even if there is a shift in this. This is the formula for a shift in time signal. So, here in our problem we are shifting x of 2t minus some form, that is t naught here is 1 by 4. That is what is being changed here. So, the answer will be Cn remains same, whereas this becomes what? This becomes multiplied by 1 by 4. Okay? The answer is B. That means 4 cos k pi by 2 by k pi is absolutely the same value as the Cn that is given to us, and the answer is minus j k pi by 4. Let us go to the next question. The next question is the average power P having Fourier coefficients which are given as follows: minus 3 comma minus 2 comma minus 1 comma 0 comma 1 2 3, 1 comma 2 comma 3 is how many watts? A, 0 watts, B, 4 watts, C, 28 watts, D, 14 watts. Okay? So, we have to find out the power given the coefficients. So, using Parsevals theorem, we can find out what is the answer for this. Okay? Let us put that here. So, here using Parsevals theorem, it is a summation from, let us say, minus infinity to plus infinity, okay, Cn of whole square. So, the coefficients are given for us. What are the coefficients given? So, we can put this as minus 3 whole square plus minus 2 whole square plus minus 1 whole square plus 0 square plus 3 square plus 2 square plus 1 square. So, this I can write as 2 into 9 plus 4 plus 1. So, this is equal to 28. So, the total power for the given Fourier coefficients, the total power of the given Fourier coefficients is summation, that is square of the summations is 28 watts. If you look at the choices given, it happens to be the answer C. Okay, this is how we have to see the average power, we have to calculate. The 20th question is the Fourier series coefficient of a time domain signal x of t is Cn is equal to a to the power of mod n. The fundamental time period of the signal is given as 2 pi. The value of the signal t is equal to 0 is how much? That is what we have to calculate. Okay. So, what is the question? The question says the Fourier series coefficient of time domain signal x of t is Cn is equal to a to the power of mod n, that is Cn is given. The fundamental time period of the signal is given as 2 pi. The choices given are A is equal to 1 plus a by 1 minus a, B 1 plus a whole square by 1 minus a whole square, C 1 by 1 minus a, and D a by 1 minus a. Okay. So, what is Cn given as? Cn is given as a to the power of mod n. That means a will take two values here, minus n and then plus n also. Okay. So, it will be minus infinity to certain value, then 0 to plus infinity. So, we have to take two summations here. So, let us take that here. So, the first summation, let us take it as k. This will start from minus infinity to, let us say, minus 1, because we have to take care of the first one, e to the power of j k. 2 pi is given as our answer. So, omega naught is 2 pi by 2 pi into t. okay, plus the second summation starts from k is equal to 1 to infinity because it exists on both sides. So, this will be a to the power of n into e to the power of jk 2 pi by 2 pi into t. So, if you look at this, this is k is equal to minus infinity to minus 1, a to the power of minus 1, e to the power of j k t plus this one, e to the power of n, e to the power of j k t. So, this equal to a e to the power of minus j k t by 1 minus e to the power of minus j k t plus 1 by 1 minus a to the power of j k t. So, now what you have to do is you have to just take the LCM, multiply, and then if you do all those things and simplification, and here significantly what you have to do is in the denominator, because you have two factors here with j, one is plus j and the other is minus j. So, it will be a cosine term. So, you will get a cos term in the denominator. So, we have to put this at t is equal to 0. Then after substituting this, so what you have to do is after taking LCMs here, after simplification you will get this. So, we have to calculate this value at t is equal to 0. So, when we take this at t is equal to 0, then this will become how much? T is equal to 0. Cos 0 is 1. So, this will become minus 2a. What we will do is we will write this here. So, this at t is equal to 0, this will be equal to 1 minus a into 1 plus a, okay, divided by 1 minus a whole square. So, the answer is 1 plus a by 1 minus a at t is equal to 0. So, the answer is 1 plus a by 1 minus a at t is equal to 0. So, this is how we have to solve. This has been asked almost very frequently in the GATE exams. Let us see the next question. The Fourier series coefficient of time domain signal x of t is x of k is equal to minus 5 delta k plus 10 plus 5 delta k plus 5 minus 3 delta k plus 4 delta k minus 5 minus 5 delta k minus 10. This is the signal given. The fundamental frequency of the signal is omega is equal to 2 pi. The signal is, now we have been given the Fourier coefficients, now we have to find out what is the signal. So, here the formula will be like something like this. So, it will be summation x of k, okay, e to the power of j k, okay, this we are using to represent that the series is discrete. Okay, if you combine, if you substitute this, here you have to substitute for different values. For example, one question here, one thing is 5 delta k minus 10 we said, 5 delta k plus 10. So, here in this k is equal to minus 10. So, we have to substitute all this. Okay. So, when I substitute all this, what happens is there are some series with k is equal to minus 10, there are some series with k is equal to plus 10. So, somewhere if I substitute omega is equal to 2 pi, we will get a series which we can write a cosine term in terms of exponential terms. So, you have exponential terms given to us. So, you can transfer back, you will get cosine terms. So, do all that, then we will get the answer like this. The answer is 8 cos 10 pi t minus 10 cos 20 pi t minus 3. So, that is how you use this formula and then substitute this, you will get the answer. Let us see the next question. The magnitude of a complex exponential Fourier series coefficient mod ak is even and its phase is minus pi. Choose the correct statement from below. Okay, here we have defined three different types of parameters here. We are giving capital C as set of complex numbers, capital R set of real numbers, and capital P set of purely imaginary numbers. Now, we have to identify whether the given signal is a real signal or is a purely imaginary number or is it a set of C minus R or none of the above. So, let us see this. So, what are we talking about here is we said the AK is even. So, the amplitude AK is even. That means it exists both on this side and also this side. Okay. Then also the phase angle given, which is minus pi. That means all this will be reversed. Okay. So, what is basically happening here? The magnitude is even, and when the phase angle is given as minus pi, what is happening? There is only a change in the sign here, isn't it? So, there is no change in anything else, it is only a change in sign. It is given function and it is a change in sign. So, x of t is element of real R. So, the answer is A. So, it is a x of t here is a part of real number. So that's the answer is now A, that is x of t is an element of R. This also has been asked a little earlier in your GATE exams. Let us see the 23rd question. The question is, which one of the following cannot be the Fourier series expansion of a periodic signal? Which one of the following cannot be the Fourier series expansion of a periodic signal? A, x of t is equal to 2 cos t plus 3 cos 3t. B, x of t is equal to 2 cos pi t plus 7 cos t. C, x of t is equal to cos t plus 0.5. D, x of t is equal to 2 cos 1.5 t plus sine 3.5 t. If you look at this, the first one is periodic, the second one is cos pi t, whereas the other one is 7 cos t. So there seems to be a periodic issue there. So the answer is B, where x of t is equal to 2 cos pi t plus 7 cos t, as this is not a periodic signal. Let us see the next question. The Fourier series of a real periodic signal has only sine terms if it is even, cosine terms if it is odd, and sine terms if it is odd. Okay. So these are the different combinations of answer. So we have to find out which of these statements are correct. A, both P and S, that is, if the periodic signal is real, cosine terms will exist if it is even and sine terms if it is odd, that is A. Then B says cosine terms if it is even and cosine terms if it is odd. C says sine terms if it is even and sine terms if it is odd. D says sine terms if it is even and cosine terms if it is odd. So what is the answer? We are talking about the Fourier series of a real periodic signal. The answer is A, that is, a real periodic signal has cosine terms if it is even and sine terms if it is odd. So that is the answer for this. Let us see the next question. Next question says, the Fourier series expansion of a periodic signal shown below will contain the following non-zero terms. Okay, you have a figure which shows, from the figure you can understand that this is an even function because it is existing evenly on both sides. What are the answers? It says choices are A, A0 and Bn, n is equal to 135. B, A0 and An, n is equal to 123. C, A0, An and Bn, n is equal to 123. And D, A0 and An, n is equal to 135. Now if you see the figure is an even figure, the figure shown is an even signal, so A0 will exist. Because this is even, Bn will be 0 and An will take two values. The value of An will be 0 when n is even and An will be non-zero for n is odd. So taking this all into combinations, the answer is D, where D is you have A0 and An terms which are existing for sure. So the answer is D.